Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJIT. Today's session we are going to start with our new chapter, that is beta and gamma function. Let's see. Firstly we have to discuss about the gamma function and its property. Let's see. Firstly, gamma function. The gamma functions of n is denoted by gamma n and is defined by the conversion of the improper integral, where integral 0 to infinite e raised to minus x raised to n minus 1 dx. This is the type 1 of the improper integral, which just depends on the parameter n. Here that is the symbol of gamma function. This type of, that is not a square root, where definition of gamma function, that is gamma n equal to integral 0 to infinite e raised to minus x raised to n minus 1 dx, where n is greater than 0, where n is any non-zero number other than negative integer. Let's see properties of the gamma function. First property, prove that gamma n equal to twice integral 0 to infinite e raised to minus x square x raised to 2n minus 1 dx. Firstly, definition of gamma function, that is gamma n equal to integral 0 to infinite e raised to minus x raised to n minus 1 dx. We required e raised to minus x square. Then for that we have to suppose x equal to t, then dx equal to 2t dt. Then where x is running from 0 to infinite, means whenever x equal to 0, then values of t, that is 0, and x equal to infinite, then t equal to infinite. Substitute this value in definition of gamma function, that will give you gamma n equal to integral 0 to infinite e raised to minus t square into t square whole raised to n minus 1 into 2t dt. Expanding this term, and 2 will be constant, comes out of integral, equal to 2 integral 0 to infinite e raised to minus t square t raised to 2n minus 2 into t dt. Then according to the properties of multiplication, x square into x, that is x3. For that, twice integral 0 to infinite e raised to minus t square t raised to 2n minus 1 dt. Here replace t by a x, that will give you gamma n equal to twice integral 0 to infinite e raised to minus x square x raised to 2n minus 1 dx. Hence prove the our first property. Let's discuss with second property, that is prove that gamma n plus 1 equal to n gamma n. Also we can written in form of gamma n plus 1 equal to n gamma n. Here according to the definition of gamma function, gamma n equal to integral 0 to infinite e raised to minus x raised to n minus 1 dx. Here we have the gamma n plus 1, then replace n as a n plus 1, means gamma n plus 1 equal to integral 0 to infinite e raised to minus x raised to n plus 1 minus 1, 1 will be cancelled out, means x raised to n dx. Then here according to the integrating by parts, means x raised to n, that is our u term, and e raised to minus x, that is our v term. Then product rule of integral, u as it is integral of v minus derivative of u integral of v and total integral, that is the formula of integration of by parts method. Then x raised to n as it is integral of e raised to minus x, that is e raised to minus x by minus 1 minus derivative of x raised to n, that is n x raised to n minus 1 integral of e raised to minus x, that is e raised to minus x by minus 1, and total integral into dx, where x which is running from 0 to infinite. In first term, applying the limits, means upper limit minus lower limit, then e raised to minus infinite, that is 0, and 0 into anything, that is 0. Here minus sign will be positive, and n which is constant comes outside, means n into integral 0 to infinite e raised to minus x raised to n minus 1 dx. Then here n which is kept as it is, and remaining term, that is a definition of gamma function, means we can written as a n gamma n. This formula is known as the recurrence relation, or also called the reduction formula for the gamma function. Let's see corollary of that term. That means gamma 1 equal to 1. For that, according to the definition of gamma function, gamma 1 equal to integral 0 to infinite e raised to minus x, x raised to n minus 1. But here n equal to 1. That means x raised to 1 minus 1, that is 0, x raised to 0, that is 1. Means our integral becomes 0 to infinite e raised to minus x dx. Integral of that term, that is e raised to minus x by minus 1, where x is varies from 0 to infinite. Then substituting the limits, means upper limit minus lower limit, then e raised to minus infinite, that is 0, e raised to 0, that is 1, then 1 upon minus 1, minus minus plus, that will be 1, means gamma 1 equal to 1. Similarly, second case, means gamma n plus 1 equal to n factorial if n is a positive integer. Let's see proof of that particular property. Then we know that gamma n plus 1 equal to n gamma n, that is the properties of gamma function. With the help of, we can written as a gamma n, that is n minus 1 gamma n minus 1. Again we can written as a n minus 2 gamma n minus 2, and so on. That means n, n minus 1, n minus 2 up to gamma 1. You all are aware about the values of gamma 1, that is 1. That means n, n minus 1, n minus 2, n minus 3 up to 1. That is nothing but the n factorial. Hence, prove that our property gamma n plus 1 equal to n factorial. For example, suppose we have the gamma 8, then it is written as a gamma 7 plus 1. According to this property, we can written as a directly 7 factorial. Suppose we have the gamma 4, then we can written as a gamma 3 plus 1. Then according to the properties of directly, we can written as a 3 factorial. Let's see another property, which is prove that gamma n upon a raised to n equal to integral 0 to infinite e raised to minus ax, x raised to n minus 1 dx, where a greater than 0. For the finding the proof, firstly we have to definition of the gamma function. Then gamma n equal to integral 0 to infinite e raised to minus x, x raised to n minus 1 dx. Here we have the function in terms of ax, means we assume x equal to au, then derivative of that term, that is dx equal to a du, means whenever our x equal to 0, then u becomes 0, and when our x equal to infinite, u becomes infinite. Then substitute this all things in definition of gamma function and simplified it. That will give you gamma n equal to integral 0 to infinite e raised to minus au raised to n minus 1 into a du. Here at this term, expanding it, then we can written as a raised to n minus 1 into a. We have also a. Then according to the a raised to n minus 1 into a raised to 1, then it becomes a raised to n, which is constant, comes out the integral. Then a raised to n integral 0 to infinite e raised to minus au and u raised to n minus 1 du. Now this a raised to n, which is comes this side, means which is goes in LHS portion, then it becomes gamma n upon a raised to n equal to integral 0 to infinite e raised to minus au u raised to n minus 1 du. Here replace u as a x, then it becomes gamma n upon a raised to n equal to integral 0 to infinite e raised to minus ax, x raised to n minus 1 dx. Let's see another last one property is prove that gamma 1 half equal to root pi. For that we have to use the properties of gamma function, which is our first property, gamma n equal to 2 integral 0 to infinite e raised to minus x square x raised to 2n minus 1 dx. Here we have the values of n, that is 1 half. Then substituting the n as a 1 half, means gamma 1 half equal to twice integral 0 to infinite e raised to minus x square. Here replace n as a 1 half, then 1 by 2 which is cancel out, then 1 minus 1 0, then x raised to 0, that is 1. Then it becomes twice integral 0 to infinite e raised to minus x square dx. Similarly, for the another variable gamma 1 half equal to twice integral 0 to infinite e raised to minus y square dy. Multiplying this both the term means gamma 1 half whole square equal to gamma 1 half into gamma 1 half. Substituting this both the equation in this equation, then we can written as in form of 2 integral 0 to infinite e raised to minus x square dx, in another bracket 2 integral 0 to infinite e raised to minus y square dy. Here simplified that term means 2 2s are 4, and both the integral which is combined together, that will becomes double integral, means 4 into double integral 0 to infinite e raised to minus x square into e raised to minus y square, which is written in form of e raised to minus, which is common, x square plus y square into dx dy. Here our x which is varies from 0 to infinite and y which is also varies from 0 to infinite. Then with the help of changing into the polar coordinates, we have to convert Cartesian to polar form, means x, when x which is replaced as a r cos theta and y which is replaced as a r sin theta. Here for the better understanding, we have the x which is varies from 0 to infinite and y which is also varies from 0 to infinite, means here we have the region in the first quadrant, and whenever we converting into the polar coordinates, at that case we taken the angular strip, that is our elementary radius vector which is up to infinite, means we have to finding the limits of r and theta. Then here r which is varies from 0 to infinite, at this position values of r which is 0 and ending point of the elementary strip or a transverse strip which has the values of r, that is up to infinite, then r which is varies from 0 to infinite, and another limit which is theta, that is our theta equal to 0, that is our initial line. Here our region which is lies in first quadrant, then whenever the movement of the angular strip in first quadrant, at this position values of theta, that is 0, at this position values of theta, that is pi by 2, means our theta which is varies from 0 to pi by 2. Then limit of theta which is 0 to pi by 2. Now substituting this limit and simplified it and converting to the Cartesian to polar form, then here x square plus y square equal to r square, you know about, which is already learned in multiple integral. Substituting the x equal to r cos theta, y equal to r sin theta, then r square common, cos square plus sin square, that is 1. Here we can also simplify it in form of, whenever we substitute x equal to 0 in r cos theta, then r cos theta equal to 0, then you all are aware about the values of r equal to 0 and cos theta equal to 0, then theta becomes pi by 2, because theta equal to cos inverse 0, then values of 0 cos inverse 0, that is pi by 2. Similarly x equal to infinite, which is r cos theta, that is infinite, means r equal to infinite but cos theta which is does not infinite, because values of cos and sin which is lies between -1 to 1. Similarly for the sin, then we can say that our r which is varies from 0 to infinite and theta which is varies from 0 to pi by 2. Substituting this all things in our equations and simplify and reduce form, that is for integral 0 to pi by 2, integral 0 to infinite e raised to minus r square into r dr d theta, because whenever we convert Cartesian to polar form, that divide dx equal to r dr d theta, because dx dy equal to mod j dr d theta, and whenever we find in the Jacobian, that is the value of r, which is already discussed in earlier lecture. Now simplified that term, then here we have the formula integral e raised to function into f dash of x dx, then we can written as a e raised to f of x plus c, which is already learned in 12th science. Then for that, to making the our integral in this form, then for that multiplying divide with -2, then our integral becomes -2 integral 0 to pi by 2 integral 0 to infinite e raised to minus r square minus 2r dr d theta. Firstly integral with respect to r, then after integral with respect to theta. That means minus 2 integral 0 to pi by 2 e raised to minus r square, where r is varies from 0 to infinite d theta. Then substituting the limits, means upper limit minus lower limit, that will give you minus 2 integral 0 to pi by 2 e raised to minus infinite minus e raised to 0 d theta. E raised to minus infinite, that is 0, e raised to 0, that is 1, then minus minus plus, that means 2 integral 0 to pi by 2 1 d theta. Then integral of d theta, that is theta, then 2 theta, where theta which is varies from 0 to pi by 2, then upper limit minus lower limit, means 2 into pi by 2 minus 0, here 2 will be cancelled out, then gamma 1/2 whole square equal to pi, then square root of that term, that will give you root pi, which is exactly prove that our fourth number property. Let's see example based on the property. First example, find the values of gamma 13 by 2. Here whenever we apply the properties of gamma function, then here we use the gamma n plus 1 equal to n gamma n. Then for that, making our function in form of n plus 1, then for that here 13 by 2 which is replaced as a 11 by 2 plus 1, means gamma 13 by 2 equal to gamma 11 by 2 plus 1, means according to this property we can written as a 11 by 2 gamma 11 by 2. For that again we simplified this term, means gamma 11 by 2 which is replaced as a 9 by 2 plus 1, that means again which is written in form of reduced form, that is 11 by 2 9 by 2 gamma 9 by 2. In similarly such a manner 9 by 2 which is written in form of 7 by 2 plus 1, then we can find 7 by 2 gamma 7 by 2. Our gamma function which is reduction in form of 11 by 2 9 by 2 7 by 2 5 by 2 3 by 2 1 by 2 gamma 1/2. Here with the help of properties of gamma function, then gamma 1/2 is equal to root pi, that means 11 by 2 9 by 2 7 by 2 5 by 2 3 by 2 1 by 2 into root 5. Then multiplying this term, that will give you 10,395 divided by 64 root pi. Similar, let's see one more example. Evaluate integral 0 to infinite square root of x into e raised to minus cube root of x dx. Firstly, how we can identify such kind of example which is solved by the gamma function? For that, whenever our function which is e raised to something power or in form of ln x or ln 1 upon x, such kind of example we apply the gamma function, and for that whatever we have the function e raised to something or ln x, then we have to supposition of that particular term. Here cube root of x means cube root of x equal to t, which is assumed, then x equal to t cube, then dx equal to 3t square dt. Now whenever the x which is 0, then t becomes 0, and when the x equal to infinite, t becomes infinite. Substituting this all things in our equation I, then I equal to integral 0 to infinite square root of x into e raised to minus cube root of x into dx, and substituting this all things in I, integral 0 to infinite square root of t cube into e raised to minus t 3t square dt. Here 3 which is constant comes out, and we have the square root of t cube, then we can written as a t raised to 3 by 2, and t square, that will give you t raised to 7 by 2. Then 3 which is constant comes out, integral 0 to infinite e raised to minus t raised to 7 by 2 dt. Here this is the converting in form of definition of gamma function. Then 3 integral of 0 to infinite e raised to minus t raised to 9 by 2 minus 1. Here according to the definition of gamma function, integral 0 to infinite e raised to minus x raised to n minus 1, then here values of n equal to 9 by 2. That means here we can written as a 3 gamma 9 by 2. Now according to the properties of gamma function, gamma 9 by 2 equal to, we can written as a 7 by 2 plus 1. Then according to the properties of gamma function, we can written as a 7 by 2 gamma 7 by 2. Again 7 by 2 which is reduced in form of 5 by 2 plus 1, means we can written as a 7 by 2 5 by 2, 3 by 2, 1 by 2 and gamma 1 half, where gamma 1 half is equal to root 5. Then multiplying this term, expanding 8, that will give you 3105 by 16 root pi. Or multiply 3 with 105, that will give you 315 divided by 16 into root 5. Let's see one more example. Evaluate integral 0 to 1 x upon square root of minus ln x dx. Here our function in form of ln x. Then obviously that is in form of gamma function, or we can solve this such kind of example with the help of gamma function. Firstly, whatever the integral which is given, that is our exactly I. Then I equal to integral 0 to 1 x upon square root of minus ln x dx. Then with the help of supposition method, then ln 1 upon x equal to t, then minus ln x equal to t, then ln x equal to minus t, then taking the anti-log, then x equal to e raised to minus t, then dx equal to minus e raised to minus t dt. Then whenever the x equal to 0, then t becomes infinite, and whenever the x equal to 1, then t becomes 0. Substituting this all the things in our integral, and our integral becomes infinite to 0. Here whenever we substitute x equal to 0, then t becomes infinite. Then our integral becomes infinite to 0, e raised to minus t square root of t minus e raised to minus t dt. Here with the help of this minus sign, limit of integral will be changed, means integral 0 to infinite e raised to minus 2t t raised to minus 1 half dt. Then according to the properties of gamma function, we have to converting in form of properties. Then for that, integral 0 to infinite e raised to minus 2t t raised to 1 half minus 1 dt. Reduce this equation in form of properties form. That means we have the properties gamma n upon a raised to n equal to integral 0 to infinite e raised to minus ax into x raised to n minus 1 dx. Here such kind of property, values of a equal to 2 and n equal to 1 half, then it becomes gamma 1 half upon 2 raised to 1 by 2. Then gamma 1 half is equal to root pi, and here denominator portion is equal to square root of 2, that will give you square root of pi by 2. These all are the examples of the practice example, which is try yourself. This is all about the gamma functions and properties of gamma function. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.